So I'm mounting the Clark pump for the Watermaker up on the bulkhead here. I need to glue some carbon plates on there, which I'll tap and put thread certs into, so that I'm not actually bolting through the bulkhead. I'm actually just hanging off the inside skin. But while I'm at it, I'm going to fix the problem of the aluminium washers for the fuel tank that are fizzing away.
So if you're going to put carbon washers on there though, and
Yep.
then with the metal,
Stainless steel bolts, yeah.
is that going to be a problem?
No, so yes, the stainless steel will react with the carbon, but not so bad. So what I can do is put Tef gel on the bolt, which helps isolate it from the carbon. Yes, if we get moisture in there, which we shouldn't, because all our windows and everything are semi-sealed now, it won't corrode. And if it does corrode, we end up with generally a rust staining. Absolute worst case scenario is we end up with a small amount of pitting on the surface, and it actually ends up, it looks more like a crevice corrosion than it does an electrolysis corrosion.
Yeah, but we're taking off. We're going to paint the
But basically, I'm
bulkheads.
getting the really shitty aluminium out.
Yeah, and we aren't going to put lining back there, so we'll be able to keep an eye on it too.
I've never had issues with stainless steel bolts going through carbon boats, other than rust stains. Aluminium, on the other hand, is just it just gets eaten up like our kids eat bread. Sparbond. So these are what the Watermaker will actually bolt onto. So I need to tap and thread. I'll put some thread certs into here, and then the Watermaker bracket here will actually mount there, and then the Watermaker will actually then be bolted to that bulkhead.
Without putting holes in the bulkhead.
Without putting any holes in the bulkhead.
And you're using Sparbond there, yep.
Yeah. So
Are you going to laminate it in as well, or just?
No. So the glue area is heaps big enough. Because my glue bond area is that wide by that long.
You've got all glue on the back.
Yeah, it's matte. Okay, so got my mounts for the Watermaker bracket. Watermaker bracket is under the vacuum cleaner and under all my rubbish there. And what we're going to have a quick little look at is how I'm actually going to bolt that bracket there with not those screws, but screws just like it, through those rubber mounts there, there and there, to this carbon plate. I may or may not have mentioned the use of threads and helicoils, and I'm just going to have a quick look or a quick explanation of what I'm using, why I'm using it. Okay, so what I'm using for this one is actually a thread cert, which is an inserted thread, and it looks like this. Let's see if the camera focus can keep up. Look, okay. So what it is it's actually a stainless steel insert, and on the inside is my desired finish thread, which my bolt will go into. In this case, this one's an M6. On the outside is actually an M8, but it's an M8 fine, because I bought these from China, They don't use a standard M8 external thread, which is a major pain in the bum. So I can't actually tap. So when I was going through the really thick high modulus carbon on my mast, I actually had to use this. You'll see these two slots here. This is actually a self-tapping cutter for the thing. So you don't actually need any drills or taps or anything. You put this on a bolt arrangement. I'll show you in a minute. And it self-taps and drills itself into the hole. When you're dealing with some quite strong pre-preg stuff, it really struggled. So it would be really advantageous for me to actually then pre-thread the carbon with a tap. And of course, this isn't a standard thread, it's a fine thread. And for me to find an M8 fine thread in Spain at the time was harder than trying to get these things. So it didn't happen, so I just struggled through. Anyway, so this is a thread Cert. Why do we use this? This is primarily used when a bolt is going to go in and out more than once. It's going to go in and out half a dozen times. Actually, if anything, a lot of times. We use these on gates on masts and things like that, where the track has to be unbolted to put the sail on and off, etc, etc, etc. These are the strongest, most reliable way of actually threading into carbon. What it also does is it increases our bearing area. So instead of a 6mm hole and thread, it's actually an 8mm hole and thread on the outside. So it's actually the equivalent of a bigger bolt holding into the carbon with a smaller bolt actually going through it. So it actually strengthens our connection to the carbon. So it's quite advantageous. Now, these have their own downfalls. They're a little bit tricky to fit at times. And sometimes... oh, come on, focus camera. Sometimes they're just not a suitable fit. Or you may not even be able to get them. So these aren't 100%, but they are definitely the preferred method now of inserting threads into composites. Now, our next method, so that's a thread Cert. What was our preferred method until we went to those were these things. And any mechanic will know what these are. These are helicoils. And these were originally designed for when you made a cock-up, particularly in your engine or in a mechanical part. You would strip the thread out. That would leave you then with a bolt that was floating in midair, and you couldn't bolt into anything. Yeah, these were to repair those threads. And we actually found them quite advantageous going into carbon. But again, these have their limitations. They have their advantages and their limitations. Their advantages are they're actually quite easy to fit. Once you know how, there's a few little tricks, but it's also their downfall in fitting them. If you don't use the tricks, you can cock them up really easily. So basically it involves using the drill that is suited for the tap, that is suited for the external diameter of, or external thread of that particular thing. This little gadget here, this special tool for fitting the thread Cert, or the thread Cert, the helicoil, and then this punch thing. This punch thing you don't really need, but it's got a strong magnet on the end of it that picks up the stainless steel end, which it shouldn't. But yeah, it's not 316 Stano. Some of them are, and this magnet doesn't pick them up. But yeah, this punch here basically snaps that little ring thingy there off. Actually, I'm going to grab one of my big M10 ones out so we can get a good look at it. Oh, there you go. Now we can see what's going on. Okay, so you can see this little bar thing here. That's what goes into this thing here. And for those of you that haven't used them, it goes on here. Trying to do all this one-handed while holding the camera. It goes on like that. So in our case here, we'd have the hole here. I'd actually thread that. So I'd use this drill here, I drill that diameter, then I use this tap here and I cut that thread in, which is not, in this case, an M10. Not an M10 thread, but the next size up. It's a special thread size, especially for these helicoils. And then this goes here like this. You put it in the hole, you screw it in. Burp, 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 burp. When we screw it in with Loctite on it or a bit of epoxy on it so that it doesn't unscrew and seals itself. But then we also need to put Tef gel on a bolt. That bolt gets screwed in so that it clears the threads and it doesn't glue the bolt in. Yeah. Once this is actually in as well, before that bolt goes in, sorry, I missed a step in the process. So this is now screwed in the hole. If we look down the hole, there is that bar in the way. Then this punch here comes in, knocks that bar out. That bar actually snaps off because you can see the little notch. I've only got one hand again, where my fingernail is there, that little notch there. It breaks off there, leaves a clean thread. The issue with these things is you can jump a thread when you're winding it in. And this turns into quite a cock up. And then you've got to extract this from the hole without mashing all your nicely threaded hole that you've just done. So generally speaking, it's quite easy. These are fairly easy to get hold of. Cost wise, I think these were expensive. The little insert bits were not expensive, but they're hard to get. A whole kit gets expensive because you need all of these special tools. And they're not actually as good for holding into the composite as the thread cert, because you can see the increase in diameter isn't that much more, and because it is a spring, it's not a homogeneous hold through the whole thing, but it does, because it is thinner, it does allow you to get away with putting it in certain areas where it's difficult to get a thicker, bigger thread cert in. But yeah, so these were the weapon of choice until these came along. Alright, so when the progression, let's say the progression of holes here, let's put this over the other side because our timelines always work from left to right. Trying to do it single-handed. Okay, so the original way we would do it is we would actually have a bare carbon hole and we just tap a thread in it and whack the bolt in, which was fine. So here's my bare tapped thing, this line in my hand. Then we evolved to the helicoil, and now we've evolved to the thread cert. And to be honest, I still use the bare threaded hole option because sometimes the length of the thread is long enough that we don't actually need massive amounts of the threads aren't loaded very heavily. Okay, so there's a whole bunch of things with threads and how they're loaded, and the depth of thread and the number of threads that are inside your part and how well they hold. So as a general rule of thumb, the minimum length of thread that you want to go into the hole is the diameter of the bolt. So in this case, I've got two different sizes here, so that's not a good indication. Let's go equal sizes so that we can see, have a good look at what's going on here. I'm going to explain this. I may as well explain it properly. Alright, let's do some apples for apples. So some M6s, right, and you're going to see here that I have two different length helicoils, and you'll notice as well the length of my thread cert. Okay, so here we have a helicoil, which is minimum requirement. So this is an M6 bolt, and this helicoil is actually 8mm long. So the general rule of thumb is diameter of the bolt, minimum length is the diameter of the bolt, so it should be 6mm long. This one's 8mm long, so it's just over. But yeah, that's the minimum requirement for an M6 bolt. To increase the strength and the holding power, we increase the length of the bolt inside. So this one is actually what we call a 2D helicoil. So it's 2 times the diameter of the bolt. So this one is a 12 mil long helicoil here. And this one is actually a 2.5. So my thread cert is actually the strongest of all, if I've got enough carbon to actually go into, at 2.5 times. I do have some 2.5. You'll see the green helicoils in there. There you go, some green ones. They're just a coated helicoil. They're 2.5s as well. So I have some 2.5D helicoils there as well. If I'm not using these, if I'm doing a part that is bolted in place and it very rarely or will never ever come out again, like a track section on my mast. What's another thing that I would bolt on my boat that never gets moved? Let's say the swim ladder on the boat. I bolt it on and I put a little bit of glue on there to seal it, and I never want it to come off again unless I need to service it. So if it does come off, it's once in a lifetime, once every 10 years it gets unbolted. Also, if I have enough carbon and meat there to actually bolt into, that it's 2.5, 3 times, 4 times the diameter. So I can I've got a M6 bolt and I have 20 mil of glass or carbon to thread into, then I actually won't use the thread certs at all. So there's actually no need to. There's actually enough strength in being that deeper bolt into the composite that it'll actually hold perfectly fine. And it's not going in and out, so I'm not going to wear out the thread. So that's the other advantage of these stainless steel thread certs, and why we use them on parts, particularly where the bolts will come in and out and on and off, and parts to be servicing, like I was saying before, the gate of the mast track, where we remove the sail track on the mast to put the sail on. Quite often, the bolts are coming in and out fairly often. It'll see a service life of bolts going in and out 20-30 times. So a metal on metal style thread is much better than a metal bolt on a composite hull. So there's 3 methods of putting threads into composites. Completely bare, no thread certs, just tap a hole straight into your composite. Then there's the helicoil option, if you've got them available to you, and then there's the thread cert option as well. Right, I'll show you the tool for putting this in compared to the toolkit for that. Let me put these in the right place. Okay, so when you buy these from China, sometimes they will come with a special tool. The ones I've always bought have never come with it, so you got to make your own. But thankfully, it's not rocket science. Okay, so I'm actually going to take my special tool out of the drill, and you're going to say, oh, that's so hard to make. Look at that. That is the special tool. So it's an M6 bolt with 2 nuts. And 2 nuts, why do you say? So the 2 nuts is actually there as a locking nut arrangement so that the thread cert doesn't ride too far up your drill. Now, there's some lessons I've learned here as well. This is the self-tapping groove here, so that this will actually drill its own way into the bulkhead, in my case, or into the composite, and cut its own thread, and everything's hunky-dory and all the rest. When I was putting these in the mast, and I'm using high-quality pre-preg laminates, I wasn't actually taking this bolt past the end of the cutting groove here. And what was happening is, because the carbon was so bloody strong, it actually crushed or squished the end of the thread cert in just a little bit. And when it did that, it made putting the bolt in really hard because it squished the end. It was a freaking pain in the backside. Wasn't I won't say it was a disaster, but it was really difficult, and that I had to go and get my M6 tap then, and then tap the inside of these thread certs just to give it clearance so I could actually get my M6 bolts in to hold my track on. So a little trick there. When you set them up, make sure that the thread comes all the way through and supports the cutting end all the way, otherwise you won't get your bolt all the way through. But anyway, let's I'll see if I can do this one-handed and film me putting this bad boy in. This could be either really cool or really disastrous. Let's see. Well, I'll have the camera in the right place, Shane. And okay, sorry about my filming there and missing half of it, but yeah, anyway, so there it is. That's gone flush with my job. Boom, screwed it in. And then make sure you use the lower speed on your drill too. That's a bit of a whoopsie when you put the fast speed on. There it goes, undoing. Oops. Oh, I've got a bit of galling. This is a good demo. I might have to get back to you folks on this one. I'll have to see what's happened with this one. I just held it, not using two hands, and I think I've cocked it up. Right, so new lesson learned. I think I actually had this happen to me on the mast, but completely forgot about it. So I had it galled. And I think I actually ran a mild steel bolt in the end, because I think I had this happen before. And obviously it doesn't happen that often, because it happened to me once and I'd completely forgotten about it. So you can see my thread here is actually galled up. Where are we? There you go. It took the top off the thread there, and it galled, and it got stuck, and it wouldn't go in and it wouldn't go out. So that bolt is actually now knackered, and that tool is now knackered. So how do I stop that for the next time? That's pretty easy. My favourite, Tef Gel. And I'll show you how I actually got it off. I used that big screwdriver there. I put it in the flat, and it actually split the thread cert open. You can see the big crack going through there when I had the screwdriver, so it split it open. Might be able to see where the thread galled up. No, but you can see the big crack down there opened up, and it came off the bolt. So I'm gonna have a new bolt and a bit of Tef Gel and do it all over again. The one good thing is though is that I actually, the hole is now pre-tapped with this one, so the next one will go in quite easy. Made some repairs to my special tool for putting the thread certs in. Basically I cut off the galled end. Now I'm going to put some Tef Gel on it. I'm going to have to actually get Anna to hold and film this while I do that. I only need a tiny bit of Tef Gel on there. So I just went around the edge picking up all the dregs. Otherwise, if I use too much, then all the carbon dust gets stuck to it and then sucks it back through. Creates another problem. So now it's Tef Gel, it won't gall up on me, and I actually put the thread cert in. You didn't get to see that one, but it's not working. So this is actually the last one going into the middle. Just drilled the hole out, get my drill. Got stuck in the carbon. There you go. Thread set inserted. That's how it's supposed to go. Not gall up and unscrew itself like the other one I showed you. But I recovered from that without any dramas, so even when it goes a bit wrong, it's actually not too hard to deal with. Now, There's a little bit of furry carbon sort of sticking out where it's burred out around the hole, so I just get some sandpaper and lightly deburr it because there's a little bit of tip gel squished in there as well. It sticks in there. And there you have it. All done. I need to find some M6 bolts and I can bolt this bracket on, see how it all fits. Okay, so got ye old post-curing heater going, and that's what our bulkhead currently looks like. Yeah, quick lick of paint, not super glam, but more than glam enough for this job.
And there you have it, fully mounted and operational. Happy days, hey Shane?
Happy days, making water.
Making water and nicely mounted. You can't even see all that hard work.